We are now at chapter 5, yeah, but from textbook it is chapter 16, Planar Kinematics of Rigid Body. This would be at page 319 of textbook. Now, if you remember in the beginning of lecture, the first video, I've actually divided the whole textbook into two parts, right? Okay, this would be chapter 16, 17, 18 and 19. And the initial will be 12, 13, 14 and 15. This first part of the block, you'll be studying, you studied on a single particle. Yeah. The second block, you'll be studying everything similar. Yeah. So the second chapter is force. This is also force. 17 is also force. 15 is work. This 18 also work. 14 is work. 18 also work. 15 is impulse. 19 also impulse. But the difference here is that this will be for not a single particle, but for rigid body. So what's the difference between single particle and rigid body? Particle, if there's only one movement at a point in time, because it's very small. If linear means linear, curvilinear means curvilinear, yeah. But then here, you can have a combination, yeah, a combination, because it's a rigid body. So if this body is moving in a straight line, at the same time, it can also rotate. So it's a combination of movement. Do you understand? So we are now at the second block, yeah. We are now at the second block. So you should master the first block before moving to the second block, yeah. Okay, so now let's go into our lecture. Planar rigid body, motion, translation and rotation. So at the end of the day, you should be able to analyze the kinematics of the rigid body undergoing planar translation, rotation about a fixed axis, like what I've told you, more than one combination at one time. Okay, now if you look at your textbook, yeah, there's nice picture that they have actually shown you on page 320. Yeah, on page 320. The newer book is actually on page 320. Yeah, my digital book is on 312 because it's an older edition. Now this is the picture that I'm actually telling you to refer. Can you see rectilinear translation? Yeah, it's straight line. Okay, whereas curvilinear is curved. Okay, and then rotation about an axis will be rotating about an axis. And then we have general plane motion, which is actually combination of few particles, okay, a few movements, sorry, on the body itself. Yeah, so that is the thing. Okay, example like this, you see this. Okay, this object, this is a piston that's moving linear, right? Linear, it's actually moving linear, up down up down up down. This arm will be moving at a curvilinear translation, because it's actually going up and down. If you see this arm, it's actually moving up and down, and this will be rotating about a fixed axis. So this is what meant by this chapter, where you can actually have combination of few movement. Okay, so the first part will be going into translation. Yeah, translation. So let me just go back to the lecture note. So the application is just everywhere, yeah, everywhere, you say, not only in amusement park. Too much of application, because in real life nothing actually moves in straight line, or nothing only moves in curve. Yeah, it is actually a combination of both. Like when you open a window or you open a door, there's a combination of curvilinear and also linear movement. Yeah, okay, and then we have the gear system, the pulley system, the cam. All this is actually moving in a combination. So if this moves, what you call rotational, this moves in a linear. So it comes here, it's rotating. So it's a combination of movement. Yeah. So there are cases that an object cannot be treated as a particle. Yeah, of course. Yeah, cannot be treated as a particle. It is most of the time it is a rigid body, and unless you are studying on an atom or a very very small particle, yeah, then only you can. So in this case, size and shape of the body must be considered. Rotation of the body about the center of mass requires different approach. So that's why we need to study. And then we have the gears, cams, and links in machinery or mechanism. Rotation of the body is important aspect of the motion as well. So we'll now start study on the rigid body, yeah, like what I've explained to you. Yeah. So in a rigid body, this is the diagram that I was referring to the textbook. Yeah. Okay, so when we have here translation occurs when every line segment on the body remains parallel. Can you see this now? This actually goes straight, right? So if you pick point A here, this will be point A. It's a straight line. Is this point B, then this will be point B. Straight line, yeah? If it's a curvilinear, what happens if a curvilinear? The path A to A, it's curved. Path B to B is also curved. Can you see they are parallel to each other? If you see the distance here and the distance here, it will be the same. Distance here, it will be the same. Yeah? Okay. So that is your translation and curvilinear translation. And then we have rotation. So this is about of an axis. So this object is actually rotating. Yeah, rotating. So in this case, particles of the body, except those on the axis of rotation, moves in a circular path in the plane perpendicular to the axis of rotation. So general plane motion will be combination. Both you have translation and then we have rotation. So translation can be linear or curvilinear, right? Two types of translation. So you can have several combination of the movement itself. Now, planar rigid body motion. This is where mostly it is actually very important, yeah? So we have like example in this body, there's three types of motion that's undergoing. The wheel and the crank undergoes, undergoes the fixed axis, rotation about the fixed axis. In the case, both axes of rotation are located in the pins, and the perpendicular to the plane in the figure. Okay, and then we have the rectilinear translation, which is the piston. Piston goes under rectilinear translation. And then we have the connecting rods, which goes to the curvilinear translation. These rods, yeah, connecting rods. Since it remains horizontal, it moves in a circular path. So the connecting rod also goes through general plane motion. This one. Okay, this rod goes through general plane motion. So it's a combination of all the movement onto one rigid body. So this is what we're going to cover on the second block of the chapter. Yeah. Okay. The first part would be on the translation, which is from chapter 16.2. Now, if you see here, RA equals to RA plus with RB stroke A. So what is this? Okay. You are in the fixed position, like what I've explained earlier. Yeah. This we saw this in statics. And also we saw this in the previous chapter. Yeah. So we have A. So from your eyes, you're looking at A and you're looking at B. Yeah, which is in a rigid body. Okay. So you're trying to connect. You're trying to have a relationship between you to A and you to B. You understand the movement, you know? Yeah. So what's happening here is that when you do that, you have RA here and you have RB. But from A to B, to establish a connection, that would be a vector diagram, right? So that is how it's generating this formula. If you see, this is a triangle, moving straight line here, and then we have the resultant here. Okay, can you see that? Yeah. So that is how you end up with this equation. Okay, so when you differentiate this equation, because this is actually position, you get the velocity. You differentiate this again, you'll be getting the acceleration, but it will be a bit unique because RBA is a constant. So therefore, what happens is that VB equals to VA, and then you'll have AB equals to AA. Yeah. Next, we'll be moving to chapter 16.3, which is rotation about fixed axis. Yeah. Section 16.3. So when a body rotates about a fixed axis at a point P in the body along a circular path, the angular position of P is defined by theta. Okay, so you see, just to make you understand it even easier to understand here, in linear movement you had R, V and A, right? So now this is rotating. So in rotating we have the angle, we have the velocity, and then we have the acceleration. Okay, so the angle or the displacement will be theta. Okay, so one revolution means one turn will be 2 pi, which is actually equivalent to 360 degrees. So what is omega? Omega is actually differentiate of your d theta over dt. or it is known as your angular velocity, omega. Yeah, and then what we have for your angular acceleration, it is your alpha, yeah, which is twice differentiating of your theta or single differentiate of your omega. So you remember what we did in the last class here? If you want to go from here to here, you differentiate, right? If you go from here to here, you differentiate. So similarly, from here to here, differentiate with time. Here to here, differentiate with time. If you reverse, then you integrate. Yeah, here to here will be integration. Okay, it's just a similar thing, but now it is just in rotation. Okay, so this is if it's constant. If you get this kind of question, it is really a jackpot. Yeah, hardly that you get a constant value. It's mostly it is in equation form. Yeah, and the next slide will actually show you the connection between the linear and the rotation. Okay, so it is written very clearly that V equals to omega R. Yeah, so this would be the linear component, which is the tangential movement. If you can see here. Okay, omega will be the angular velocity and R will be the radius. Okay, so similarly, we also have for acceleration. So alpha, yeah, alpha is connected to your tangential acceleration, yeah, multiplied with R. Whereas the AN, which is the centripetal acceleration, is omega square R, or you can say as V square over R, yeah. Okay, you know what is AN, right? AN is towards the center of the thing, and AT is tangential movement. So you have got two velocities here. Yeah. So now, if you were to combine, what you get here is that, yeah, of course, A is a combination of A tangential plus A normal, right? Centripetal. So you have an equation which is actually combining, which is alpha R and your omega square R. So when you derive, you will get that this is actually minus. Okay, so we have completed this. Okay, how to answer a question. Yeah, so first thing, of course, to establish the sign convention, and then in relationship known between any two variables. Yeah, and then you try to connect them with this equation itself. Yeah, and to determine motion of a point, you can use the scalar equation. Okay, all these formulas can be used. Now, let me just show you an example. Yeah, then you will understand it better. Okay, you can just go through the example in the lecture note itself, but I'm going to go through example 16.1, which a bit more challenging. Okay, so a cord is wrapped around a wheel in figure 16.6, which is initially at rest, okay, when theta is 0. So where is the theta at rest? So it will be somewhere here, right? This is your 0 point. So as the point P actually moving down, of course the angle increases. Okay, if the forces applied on the cord gives an acceleration of A, look at that, A equals to 4t. It is not a constant value. It is actually in a form of time, yeah, where t is seconds, and determine the function of time. So they want you to calculate the angular velocity, which is the omega, and they want you to calculate the angular position, which is the theta. Okay, so that is what the question requires you to do. I'm just going to erase all this. Okay, now let's look at the working. So for the first part, yeah, so we have calculating the omega itself. So from the previous formula, we know that the A tangential equals to omega R. Not omega, alpha R. So 4t with 0.2, R radius is 0.2, is given in the question, 0.2. You multiply, you get the first equation, which is the alpha equals to 20t. Okay, now if you want to find your angular, okay, if you want to find the angular velocity, what do? You integrate, yeah, because you are at alpha, you want to find your omega, you actually integrate. So when you integrate with time, what are the hints that's given? Initially at rest when theta is 0. So that is the hint. Can you see that? 0, 0. So omega final with the time final, we don't know. So when you integrate, what you have that is that omega equals to 10 t squared. Okay, so the first part is done. Okay, part B, they're actually asking you for angular position, which is the theta. So let's look at how to find the theta. Of course, you integrate this, you get your theta, right? So what are the hint that's given? Also 0, 0. At theta 0, the time is 0. Okay, so when you integrate this 10 t square, you will get that theta is actually 3.33 t cube radian. So this, I hope you can understand this example. If there's any problem, then you can meet me on the consultation hours itself. Yeah, I'll be moving on to the next chapter 16.4 in the next video. Thank you.